So this is something like we're going to be of the class A, class B, class C. We need to create proper geometrical set. Now, if you want to rearrange, okay, if you want to rearrange, so now I have a closed volume separately. So now I need to add in work. So I'll just right click, change geometrical set. You can go to the work again. We need to rearrange these three in closed volume. Again, right click, select object, and go for change geometrical set. You can change and you can add somewhere here. So definitely we need to have in inside this, so last position we need to have. Okay, so this is how we can rearrange a geometrical set. So first of all, we need to take a class A. So here you can find, we need to find tooling line. So that also we can add the geometrical set tooling line. And now if you just check, like we need to add a join. So select the join for the class surface. Definitely always we get a class surface in patch. Then go for the distance propagation. Select OK. Then you can check for the boundary if any. There is a joining tolerance we need to reduce. So for time being, you can go for that reducing 0.01. Again, you can check if anything is any surface is open or there.
Excuse
No.
me, sir.
Yes.
Sir, what if we get input as a single surface, sir?
No issues. You can directly get that, join that and check if there is any opening or not. That is
Sir,
a no issue.
there is, if it's only one surface, we cannot use join, right, sir?
So this is only one surface. Okay. Fine.
Okay, sir.
Okay. Now this is a one surface you're talking about. Clear? Now we need to join this surface. Okay. And now we need to check if any opening is there. Got it?
Okay, sir.
Okay, if you just check like 0.001 we have. So in that case, it having opening somewhere. So then I will pay special and check for that. So here you can find there is opening in surface. Okay, even it is a single surface, there is opening. Clear? So
Yes,
definitely
sir.
we're going to be check how we can solve this error. But you can join even the single surface to minimize that accuracy. You definitely need to join. Something like this you can see. You can find something like this we can have. Okay. So this is the classes surface we have, and definitely we need to find tooling line. So from where we can start with. So we need to start with having a point somewhere at the center. So you can select 0 will be give you the perfect center with the surface. Okay, definitely we need to isolate, double click for the coordinate. So this is how we can check. Now we need to add the tooling line. So this part is going to be get assembled. This part is going to get assembled into X. Okay, so if you just check, like this is nothing but the location of the part. So this part is located somewhere at a center where we have the number of buttons. Okay, so here you can find the number of buttons we're going to be have, and then after that we're going to be have the screen. So here somewhere we're going to be have steering. Okay, so this parking button, as the name suggests, is going to be used for the parking light below. So why are we going to be use the parking light? So this is something like whenever the vehicle is not operating and if it's a breakdown onto the road, so definitely we need to blink the light to highlight there is a one vehicle to catch the attraction. So definitely this is something like the function we have to blow the light. For that reason, what are the normal function have for this particular button? So any button having the normal function to blow the light of the light, so same function we have over here for this button. So now we can check. This is going to be assembled into the X. Okay. So as we already seen, whatever will be the tooling direction that near to assembly direction. Okay, so here the assembly direction is X. Okay, so assembly direction is X. So we'll try to find the direction nearby X or exactly X. So now we will just have one X line to check draft analysis. Okay, so over here we're going to be have the X line, and to that we need to have now draft analysis. Go for the analysis, something like here we have. So we need to always do twice. Compass need to get position. Now we need to select the surface, class surface. Okay, so here you can find, so class surface with respect to X with the draft angle 2.998. Okay, so this can make it as a 3 degree. We are checking for the draft analysis. In this area we have the value 5.9 somewhere here, 5.9, 5.3 is 9 somewhere. Okay, so this will be less than 6, but again it will be get removed close to 5.9 somewhere. It's going to be get removed, but for our study purpose you can find this is not a perfect. We require 6 degree, and in this area we have close to point not something. Okay, point not something, it's not again the 0.1 as well. Okay, something like this we're going to be have less than that. So whatever the addition of this two is not matching to the 6. Okay, so here in this area we're going to be have point not 5 somewhere, and in this area we're going to be a 5.9 1 2 3 something like we're going to be have. So addition of these two should be 6. Okay, so here we have close to or managed to go for the 6 degree addition of this surface to this surface. Whenever there is a V condition, whenever there is a V condition and your tooling line in between somewhere here, so with respect to tooling line this surface should be 3 degree. With respect to tooling line this surface should be 3 degree. Here you can find, so both surface having 3 degree draft. So the total distance, total draft angle between these two has to be 6 degree. Okay, so total we need to have 6 degree. So here what we are getting, something like close to 6 degree we are managed to get. Okay, this surface managed to get over there. Now I can find how much is this particular draft. Okay, if you can check, this is, we have somewhere close to 8. One more thing, how we can log this particular value. If you just check, like if you want to lock, even I can just move the point, it is not going to be get moved. So always you can right click on that DT somewhere, and here you can have the option unlock or the lock. Okay, now some here also you can check, we have close to 7 degree angle. Okay, so somewhere here we have the 7 degree angle. So when you can lock this, unlock this from here. And another area, another surface, we have -1, -1.1, -9 somewhere, -4. Okay, so maximum we can check where exactly the minus maximum 1 we have. Okay, so here you can find it's something like 1.7. Okay, so 1.7 here, and another side we have 7 point. It's close less than 7. Say we have 6.7, and in opposite side we have minus 1.6 somewhere. Okay, so now we can check the addition of these two surfaces. Okay, so addition of these two surfaces has to be 6 degree. Okay, so addition of these two surfaces has to be 6 degree. If you just check this surface to this surface, we need to have 3 degree with respect to tooling line, 3 degree with respect to tooling line, and here we have 3 degree, 3 degree, and total we required 6 degree. And here we have 6.7, but here we have 1.6. So if you just go for addition of these two, the answer will be, what will be the answer, anyone?
5.1.
5.1. Can it be okay? 5.1 degree, how much we required? We required 6 degree.
4.9.
Okay. So 0.9 degree is falling short. Okay. If you are trying to rotate the line by any value, if you are trying to rotate the line, like tooling line by any value, it is not going to be get you the perfect line. Once you rotate in this direction, this draft will not be fulfilled. Okay. So there is always a 0.9 degree shortage. If you have this 3 degree surface to get clear with the line, then again another will be 2.1. Okay. So there is always a shortage of 0.9 degree you can find. So in this case, in this scenario, what we can do, considering assembly line as a fix, we need to modify the classes surface. We need to modify this classes surface to make sure it will be feasible for manufacturing. Okay. So anyone, what will be the reason to have this depression? Any logic? What is the reason to have this particular depression over here, this area? Any logic? What is the function of this particular part? Yes,
To
anyone?
getting press. To getting
Exactly. So to get that press, what is required?
force or
Force.
pressure
Yes. Other than
in
this,
tooling
to get the proper force get transfer, what you required?
direction.
Yes, that is fine. You might have gone with that knurling operation. Okay. So that knurling thread is available. Why that knurling thread are available? It might be on
For
handle, it might be on screwdriver, it might be
For gripping, sir.
exactly, exactly. So what are the slot provided here is just to better grip, to make sure your finger will not be slip. Okay, your finger will not be slip. So that is only the function we have over here. Clear? So whenever we are blowing that light, we should get that grip. Okay, kind of thing is considered. So as we have received this as a style, so there should not be any particular, there should not be any particular, there should not be any particular reason to have these particular surfaces, all the surfaces in different angle rather than 3 degree, because 3 degree is our tooling angle that we required. Okay, and without that we cannot manufacture the part. So this is something like the reason we have 3 degree. So now what we can do, we will try to replace the surface. We'll try to replace the surface. We'll modify the classes surface by keeping tooling line as the same. By keeping tooling line as the same, we'll try to modify the surface, and here you can find how we're going to be modify surface that we will check today. Okay. So already we have seen the option one. Option one is something like we will not modify surface, we'll modify tooling line. Okay. So CAS will be same. So now this will be the option one. What we are doing in option one, we are keeping style as fixed and modifying tooling line. But in option two, what we are doing, in option two, we'll keep tooling line as a fix. Okay. So we'll keep tooling line as a fix, that is something like X. And now we will change for surface. Okay. So we'll change for surface. So we'll not keep same surface. We'll not keep the same surface. We will change the surface now. Okay, so first condition we already seen A pillar lower. So this is the second condition we're going to be checked today. Okay, how to modify the surface, then replace into the existing one, so that we can check today. Okay, so this is the option 2 we're going to have. Without changing tooling line, we can change the classes surface. So whenever there is a condition occur, we need to first confirm with the studio department. Like this is something like we need to require to change the surface due to the tooling feasibility, and definitely that we need to modify. So first of all, what are the classes surface we have, so that we can keep over here? That is nothing but the input classes surface, so that we can rename also input class A, because we need to modify now class A surface. Okay, so that will be the final class A. And there will be the modification geometrical set we can add. Class A modification. Okay, so that geometrical set we need to add over here itself in class A. So now we need to modify the classes surface. For that, what will be our strategy? So strategy will be something like, we need to find first curve at the bottom. From that curve, we can have a sweep of 3 degree. Okay, so that will be fulfill the tooling requirement. Okay, so this is something like the surface we need to create. For that, we required this bottom curve. Okay, so how we can find that bottom curve? We'll have the surface from the bottom over here as well as the vertical surface. So we'll extract them, try to make the intersect, and we'll get that curve. And from that curve, we'll have sweep. Okay, so first of all, we need to extract the surface. So we can extract the bottom one, and we need to go for untrim command. Okay, so here you can find the untrim command in join. We need to go for the untrim. So this is how we're going to get the untrim surface. So this we can extrapolate unlimitedly. Okay, so here you can find, so in all the direction with curvature continuity, we can extrapolate it unlimitedly. Something like this we require. Okay, and sometime it is not feasible to extrapolate this surface that particular extent. Okay, so sometime it is not possible, but here it is okay. But you can check, like always it is better to go for untrim and then extrapolate. Okay, so we'll get that original surface. Now again we need to have that vertical surfaces. So there is no one single surface, so we need to extract multiple surfaces. So don't use the multi-extract command, use the single extract. You can find we're going to be have the single extract. And make sure we will join. Okay, we will join this command. Okay, so with this we're going to be join, then distance propagation, and then go for extrapole. Okay, so we can just go for extrapole this with the boundary. It will be easy to extrapole. Okay, so value you can check. I can find it's going to be get extrapole, and also it's possible to get intersect. Okay, so we'll use this intersect command. Element first we can select, element second we can select. We'll have the intersect over here, and with respect to that, we'll have a sweep. Okay, so we'll have a sweep with respect to tooling line. So in sweep command, you can check, we have with the drop direction, select the tooling line, select the drop direction. So select the curve first, then select over here drop direction. Okay, we have the tooling line, and the angle we need to give 3 degree. So this arrow is very difficult to manage or check like in which direction it's going. So better to add some extra angle, 20, 25, something like 15. So better you can understand in which direction it's going now. So the direction you have selected is correct. I need to only give the angle 3 degree. Okay, something like it will get. And the length you can select from here. We'll just go for the extra additional length. somewhere like 30. So there is another surface, you need to hide that, you need to have the sweep. So we will trim these two surfaces, the sweep and the original surface. We can trim something like, and what are the existing fillet we have in input, so that we can measure. Okay, we can measure this fillet. So here we have the 1 mm. Okay, so R1 we can do the fillet. So here we can add R1. Clear? So this is going to be at the R1. And with respect to this, we're going to be add the upper surface as well. So this top surface we need to extract and try to make the surface which is common we can add. Okay. So to change the surface is not a big deal. What is the big challenge you have over here? Modify the surface, and that surface you need to integrate in existing surface. Okay, so existing input surface without changing much surface. What are the required surface we have? So that much only we can change and we can add over here. So how we can do? So here we can extract the top surface as well. Okay, so this surface we can extract, and that is also the same thing we need to do. We need to go for untrim. You can select this surface, this surface. At a time we can do the multiple surfaces in this. So now we'll get that untrim command. So we'll join this surface because they are the two surfaces. We'll join, again go for trim operation. So again you can select the trim from here to here. Again we're going to be add fillet. So again fillet we need to check as per the input what are the upper fillet we have. Okay, so upper fillet we have, it's something like 3.5. So 3.5 mm fillet we need to add on top surface. Okay, always use hide, show, right click, then you can find the underscore is nothing but the shortcut. Okay, so here work define is underscore is F, is nothing but the shortcut. Okay, so whenever you just do right click and click on H, it will be automatically hide and show. Okay, don't use any particular keyword rather than space, another F8, F9, whatever any other key. Okay, so by default CATIA having this practice. Okay, only you need to click right and then you can put over there. So by practice you'll get that, because whenever you change the system many times, it happen like in workplace, whenever you're working into the office, there are the n number of systems. Okay, so for that reason you'll set anywhere, somewhere you are setting, so another day you are sitting on another system, again you need to go for the settings. Okay, so this is a CATIA setting we have. So try to use this CATIA setting, right click and click H by keyboard. Okay, so here we need to go for the 3.5. So 3.5 mm fillet we can add. With respect to that, we'll get the surface. Okay, so biggest challenge now we have is something like add this surface into the existing one. Okay, so add this surface into the existing one. So what we have changed, we have changed this surface. So whenever it is less or more, the surface will be going inside outside 3 degree. Okay, so now what we can do, what are the surface we have? Okay, what are the surface we have? This extracted surface. Okay, so what are the extracted surface we have? So that we join, we will split with the common boundary. Okay, what we need to do, whatever the surface we have, so we need to create one common boundary, something like this, and from that common boundary we will split classes surface as well as whatever we have created. Both surface we will split and we will add over here. Okay, so what we're going to be have, something like this we have. So we need to join. So this we will join, we will select the boundary, because in this surface we have not changed anything. In this surface we have not changed anything. So for that reason, you can find we only extract the surface, and from that we have taken the join. Now we can just split with this, we'll get something like this much surface. Okay, and already what are the remaining surface we have, so that we have created. So this is the remaining surface we have that we have created, but still we need to split with the boundary because there should not be any extra additional edge. Okay, so this is a one surface we have. This will be another surface we have. So these two we need to just join now. Okay, so these two we need to just join from this to this. If we join, we'll get the surface, and definitely can check for the boundary. So there is no opening somewhere. Again, what we need to do, we need to do the draft analysis. So here we have the existing draft. So you can just select material mode, check for the reverse, and you can find now what are the surface we have, that is all together 3° everywhere. Okay, so this is something like the modification we need to do onto the surface. If the class surface is not proper, somewhere there is a tooling issue, and we know that style will agree over here because the functional requirement is to have something like this, and this is how the iteration of the style will be happen. Okay, so right now here we have the iteration, style surface need to get modified. Okay, so this is something like we have modified the option 2, changing classes surface by keeping tooling line fixed. Okay, so tooling line is fixed, we have changed classes surface. Okay, so anyone having doubt here, any doubt till now?
Hello, sir. Could you please explain once again joining of that new surface with the old body?
Okay, no problem. So here you can find whatever we have created this surface, we can directly select the boundary of this, but we have done the untrim, so we don't know little bit extra surface will be go outside or what. Okay, so what we can do now, whatever we have already extracted the surface. Okay, so what we can do, for your convenience, I can extract this surface again. From here to here we have extracted the surface. Okay, and we can have the boundary, join them, and we'll have the boundary. Okay, so what we can do, we can join them together and we have boundary. Okay, so this is something like we can select the boundary, and this boundary we can use to split class A. Okay, so we'll split the class A surface with respect to this boundary, something like here we're going to be have. Okay, so similarly the another surface we have, so that also we're going to be split. Okay, so whatever we have the another surface that we already create modified, so this surface also we need to split with the boundary. Okay, something like this we can split, and to just highlight you, I will just color, and then definitely we need to join these two. Okay, so what are the surface we are replaced, we are replaced this surface, but what happened, due to the change in surface, this fillet also get changed. Okay, so due to change in surface, this fillet also get changed, and this highlighted line, okay, this highlighted line is also get changed, it gets shifted, deviated with respect to tooling given surface. Okay, so what we can do now, we'll just go for the join this to this, and with respect to that we're going to be get a single surface. Okay, so this surface we can name as a modified class surface. Okay, modified class A, we can name this, and now we can use directly this for the offset. So here you can find we have class B, we'll go for the offset. So same thickness you can use 2 mm to go for the offset. So definitely we need to have color coding. So opposite direction we need to go for class B somewhere here. Okay, and then we need to go for closing the surface. So closing surface we need to do with respect to surface or tooling line. So here we have the surface as well as tooling line. So we'll try with surface, wrap direction 90° we can do. 2 to 3 mm it's fine. So we'll have something like 2 to 3. Get this surface. Now we need to trim. Okay, so we need to trim class A, class B, and class C. So here you can find we need to have either a geometrical set, newly added closing surface, or trim surface, or you can directly have trim over here. So we need to trim class A, class B, and class C. Okay, so you can find we have this as class B and this as class C surface. Okay, so this is something like we have class A, class B, and class C. So we need to trim class B to class C first. So you can find something like this. We can trim. Again, we need to trim this two with this. Okay, and this we can name as close volume. Okay, we will join this and name this as close volume. Something like this we can do. We have the color for this part. And we add, insert, body, and then go for the close volume. So you can find always we can get that over here in this command. Select. You can find we can create this as a close volume. You can name this as close volume. Hide this, hide the surface, we'll get the part. Now we need to check again draft analysis for this. So we'll go for the checking or draft analysis for this particular part. So where we're going to be get the parting line. Parting line is nothing but where the core and cavity get separates. Okay. So here the separation of green and blue line will be parting line. So we need to add the geometrical set parting line. Okay, either you need to extract this surface, that will be fine. You can extract this surface, tangent continuity, point continuity, or else what you need to do, you can just have extract the classes surface. Okay, you can extract the classes surface with tangent continuity, and to that particular surface you will have the boundary. Okay, so this will also going to be give you the parting line. So here you can just have that line type will be similar to that what we required, and this is something like you can again check draft analysis, you get that result. Something like this, you can get that result where we have core and cavity separate, there we have parting line. Okay, so this is how we have found the tooling line. Okay, that is a X. We have changed the classes of S, as well as we have done the close volume and then parting line. So this kind of the CAD test you might get for 2-year experienced person to find the tooling direction. If there is any technical help you required, you need to change the surface tooling requirement. You need to change the surface. Again, you need to do the close volume and find the parting line. So 2-year experienced person, you might get this kind of the CAD test in any of the interview.